All right, guys, we're going to look at solving exponential equations. So we think about exponent rules and things like that. And when we think about these problems, we want to get the bases the same on each side. So we're using properties of exponents to simplify each side. We're going to rewrite each equations where both sides have the same base. And what I mean by base is, like on number 1, you got a base 2 on each side. Number 2, you got a base 5. So that's the big number that has the exponent. And once we get the bases the same and everything simplified, then we can set the equations or the exponents equal to each other and get an easy equation to solve. So with number 1, we have bases that are already the same. There's nothing to simplify on either side. So we're just going to drop the 2's and set up the equation x plus 1 is equal to 9. And that'd be 8 as a solution because you subtract 1 from each side. Number 2 is a similar situation. You got 5 on the bases of each side. There's nothing I can do on either side to simplify anything, so I'm just going to drop the 5's and get 4n plus 5 is equal to n minus 7. I'm going to solve that equation for n. So I would subtract n and subtract 5. So it's going to be 3n is equal to negative 12. And I divide by 3. N is equal to negative 4. When we get down to number 3 and number 4, they're a little bit more difficult because you've got more than one thing on one of the sides or both sides. So for number 3, you've got 3 to the k power and 3 to the k plus 2 power. So on this side, we've got some things that we need to simplify. And the way exponent rules works, if you're multiplying things that have the same base together, you do what with exponents? You add them. So like x squared times x to the second is, or x squared times x to the third would be x to the 3 plus 2, which is 5. So here in this case, since it's variables, we're going to have 3 to the k plus 2. And then the right-hand side, nothing needs to be changed. So on the left-hand side, we can simplify that and get 3 to the 2k plus 2 is equal to 3 to the 5k minus 1. And now the bases are the same on each side, so I drop them and set the equation up. 2k plus 2 is equal to 5k minus 1. And then subtract 2k, add 1. 3 is equal to 3k. Divide by 3, and k is equal to 1. That's the solution for that problem. Okay, look at number 4. We've got base 10s on each side. So on the left-hand side, you got 10 to the negative 4 and 10 to the 9th. We're going to add those two together. So that'd be 10 to the 5th power. On the right-hand side, again, same base. And they're multiplying, so we're going to add those together. So v plus 4 plus 2v minus 11, like terms. 10 to the v plus 4 plus 2v minus 11. And we simplify that, 10 to the 5th equal to 10 to the 3v minus 7. Again, bases are the same, so we drop them. So we get a nice, easy equation to solve. Add 7. 12 is equal to 3v. Divide. And v is going to be equal to 4 in this case. Really nice. Okay. Now, the second type of equations that you could have are where the bases are not the same. And we've got to rewrite them. So we want to think exponentially here. So when we see a base on one side, especially the side that has the variable, we want to look at the other side and say, can I rewrite that with that same base? So with number 5, you got a 6 as the base on the side with the variable. And can I rewrite 36 as 6 to a power? We happen to know that 36 is 6 squared. So this is 6 to the 2x minus 10 is equal to 6 squared. And now the bases are the same, so I can drop them and hit 2x minus 10 is equal to 2. Solve that problem. Add 10. 2x is equal to 12. Divide by 2, and x is 6. Okay. Looking at number 6 here. We got on the left side where the variable's an exponent. We got a base of a 2. So what is 8 with a base of a 2? 2 times 2 is 4, times another 2 is 8, so that's 2 to the 3rd power. So we got 2 to the p minus 7 equal to 2 cubed. Drop the 2's. And we get p minus 7 is equal to 3. Add 7 to both sides. My brain is doing the work before my hand is. Get 10 as a solution. Okay. All right, a little bit more difficult when we get to number 7. We got a base of a 7 on the left side with the 4x plus 11. So we want to rethink how do we write 1 over 7 with a base of 7. And anytime you see a fraction there, your brain should automatically jump to negative exponents. Okay, so we got 7 to the 4x plus 11 is equal to 7 to the negative 1. That's the same thing as 1 over 7. And then we drop the bases. So we get 4x plus 11 is equal to negative 1 and solve this problem. So we're going to subtract 11. It's going to give us 4x is equal to negative 12. Divide by 4. X is negative 3. So anytime you see a fraction, you got to think negative exponents. Okay. Number 8, they turn it around on us. They put the variable on the right-hand side, but we know that we're looking at this 2 that's the base. So the big 2 that's here. How can we write 32 as a 2 to a power? It's 2 to the 5th power. And so our equation that we're going to set up is 5 equals 2m minus 9, because we're dropping off the base 2's. Add 9. 14 is equal to 2m. Divide by 2. 7 is equal to m. Okay. All right. Number 9, a similar problem. We got a base 3, but here we have variables on both sides. So we look at that and we say, okay, well, which one of those bases do I go by? Go by the smallest one. The smallest base is a 3. So how can I rewrite 27 as a 3 as a base? 27 happens to be 3 to the 3rd power. So we really have 3 to the 2x is equal to 3 to the 3rd raised to the 2x plus 6. So this one's a little bit more complicated. All right. So here's what's happening. Exponent rule says you multiply those two together. So we're going to distribute 3 to the 2x and to the 6. So that's 3 to the 6x plus 18 is equal to 3 to the 2x. Now the bases are completely the same, and I drop those. You get 6x plus 18 is equal to 2x. I'm going to subtract 6x. 18 is equal to negative 4x. Divide by negative 4. And reduce negative 9 over 2 is equal to x. Okay. It's okay, we get a fraction answer. That happens. Part of it. All right. Let's look at number 10. We got a 4 as the base, 4 to the y plus 2, and 16 to the y minus 3. So we think about those bases. Think, can I rewrite 4 is the smaller one. So can I rewrite 16 as a 4? We happen to know that 16 is 4 squared. So this is 4 to the y plus 2 equals 4 squared to the y minus 3. And again, it's the same rule. We're going to distribute this 2 to both of those. So that's 4 to the y plus 2 is equal to 4 to the 2y minus 6. And again, I'm going to drop the base 4's. Y plus 2 equal to 2y minus 6. Solve that problem. So I'm going to add 6 and subtract y. 8 is equal to y. Done. Okay. All right. So here, changing the base of one side. Okay. Into a little bit more difficult problems here where we have to change the base maybe of both sides to be able to do that. So let's look at number 11 there. 125 to the y power and 25. Okay. So 25 squared be 25 times 25. And I know that's a lot bigger than 125. So I know 25 can't be my base, even though it's a smaller number here. So, but what can I rewrite those as? Well, I happen to know that 25 is 5 squared. And I know that 125 is 5 to the 3rd. So it ends up being 5 to the 3y. And the bases cancel out. You get 3y is equal to 2. Divide by 3. You get a fraction again. That's okay. 2/3. Let's look at number 12 there. You got a 16 and an 8. I know 8 squared is 64. That's a lot bigger than 16, so I know I can't do 8s. So I think, what can I write 8 as exponentially? I know that 8 is 2 cubed. I know that 16 is 2 to the 4th power. And I'm going to multiply these together. That's 2 to the 12x. Distribute on that side. It's 2 to the 3x plus 6. Now the bases are the same. Drop them off. Subtract. 12x minus 3 would be 9x equals 6. I'm going to divide and simplify. Divide by 9. 6 over 9 reduces to 2/3. Okay. Right, looking at number 13. 4 and 8. 4 times 2 is 8, but that's not exponential. That's just multiplication. So I think 4 is 2 squared. 8 is 2 to the 3rd. Multiply it out. 2 to the 6x. 2 to the 3x minus 3. So it's just multiplying the exponents. Drop the 2's. Solve it. It's 3x. 3x is equal to negative 3. X would have to be negative 1. Okay. Number 14 gets a little bit more difficult. Anytime they throw fractions in there, it looks a little tougher. But this one, it made it a little easier because this is actually 1/3 is easy to change. It's 3 to the negative 1. So if I change that base to a 3, I think I've got to change the 81 to a 3. And it's 3 to the 4th. And as you do more of these, you'll figure out, and memorize some of those. And if you're not sure, you can always do a factor tree. And that's how I'm getting 3 to the 4th power there. 81 is 4 3s. Okay, so here we're going to distribute 3 to the 8x plus 20 equals 3 to the negative 2x. And I'm going to drop my bases. 8x plus 20 equals negative 2x. Subtract 6x. 20 is equal to negative 8x. Divide by negative 8. And reduce. So that'd be 4 goes into both of those. 5 over 2. Negative 5 over 2 is equal to x. Okay. 15. And we got an 8 and a 32. So anytime I see those numbers, it makes me think of 2's. So I know this is 2 to the 3rd. So the 2a minus 1. 2 to the 5th. To the 2a plus 1. And I want to distribute 2 to the 6a minus 3 equals 2 to the 10a plus 5. And then I'm dropping the bases. 6a minus 3 equals 10a plus 5. That's the equation I'm solving. So I'm going to subtract 6a, subtract 5. That's going to be negative 8 is equal to 4a. And so a would be negative 2. Number 16, same idea. We're trying to rewrite things with the same base. And I've already seen 27. I've got some experience with it. I know it's 3 cubed. So what about 243? And let's just divide it by 243 divided by 3. So it's 81 times. Divided by 3. Divided by 3. Divided by 3. So 1, 2, 3, 4, 5 3s. So 3 to the 5th power. X minus 2. And again, I'm going to multiply. So 3 to the 6x. 3 to the 5x minus 2. Drop the 3's. 6x equals 5x minus 2. Subtract the 5x. An easy problem here. That's going to be x equals -2. All right, number 17 is a little bit more difficult because you got more than one thing on the right-hand side, and it's a base 4. So I've got to remember that this 4 here has a 1 exponent, and the rule for multiplying things with the same base is you add exponents. So this is really 4 to the 4x plus 1, and then 64 is 4 to the third power. So remember that from our sums and differences of cubes. And then now got the bases the same. 3 is equal to 4x plus 1. So we're going to subtract 1, divide by 4. X is 1/2 in this case. Okay. 18, again, you got bases that are the same on the left-hand side, so we're going to go ahead and combine that by addition. So that'd be 2x plus 2x is 4x. And then 1 over 81 is 9 to the -2, because I know 81 is 9 squared. And now I have the bases the same. Again, nice. 4x plus 4 is equal to -2. Subtract 4. 4x is equal to -6. And I would divide by 4 and reduce that fraction to be -3 over 2 is x. A couple more here. We'll call it a day. All right, so let's look at number 19. We don't have the same base on the right-hand side. We got 49 and we got 7. So I know 49 though is 7 squared. And then I know 1 over 7 is 7 to the -1. Now everybody's got the same base, but I'm going to simplify the right-hand side. So that's 7 to the 2x minus 10. 7 to the x minus 9. Again, this is 7 to the -1. And then I'm going to combine like terms here by addition. So 2x plus x is 3x. And then -10 minus or plus -9 be -19. And now I got the bases the same. Drop them. -1 equals 3x minus 19. So I'm going to add 19. 18 is equal to 3x. Do some division. 6 is equal to x. All right. 20, another difficult one. Looks like base 4. So we have both sides have a base 4 there. 16 on the bottom is going to be 4 to the -2. This is 4 to the 6x plus 18. And then that's why I would add these together. So that'd be 4 to the 2x minus 2. 4 to the 6x plus 18. Drop the 4s. 2x minus 2 equals 6x minus or plus 18. And try to get it all together. So I'll subtract 18 and subtract 2x. That's going to give us -20 is equal to 4x. Divide by 4. -5 is equal to x. It's all about getting the bases the same on each side and then combining like terms and dropping the base and get the exponent equation. It's not as complicated as it looks when you first get into it, so it's not too bad. So work your way through those. If you got questions, please ask. I'll be glad to explain things to you.